And we're live. So let's get this show started. The sun rises in the horizon. It is the morning of April 2nd, 22nd, 2001. Floating at 408 kilometers above the sea level is the International Space Station, an orbiting laboratory and research station in space. Canadian astronaut Chris Hadfield has been training for a year and a half to install a new robotic arm. He has spent countless hours studying and training for his first spacewalk. Early that morning, he spent a few hours polishing the visor of the spacesuit, mentally rehearsing the procedures he had practiced during those 18 months on a pool back on the ground. After about 4 hours of preparation, when the airlock has finally depressurized, Chris grabs the handle and starts walking out of the station. The scene is a breathtaking visual experience. The vibrant colors of Earth, shining reflections of the spaceship, and the profound blackness of space. 5 hours in, the installation is going well, when suddenly he becomes aware that droplets of water are floating inside his helmet. He tries to ignore it, but suddenly his left eye starts stinging. He tries blinking repeatedly, shaking his head from side to side. He decides to continue. He still has one good eye, but now is starting to fill with tears. And in space, the tears don't flow downward. They just sit there. And as he keeps crying, a bigger and bigger bowl of salty liquid accumulates in his eyeball. When suddenly, it's all darkness. Chris is effectively blind, drifting in space at 28 kilometers per hour. Good afternoon. My name is Ignacio. I'm a software engineer, and today I would like to discuss with you the value of the seemingly small things. The inspiration for this tech talk came about a year ago when I bought 2 books about 2 things that I'm passionate about. One was about space and life as an astronaut, and the other one was about programming. So if you're concerned about our friend back in space, don't worry, we will get back to him later during the talk. In 1973, authors published a paper titled Perception in Chess, where they compared the abilities of experts and beginners to remember the positions of pieces in chess. When the pieces were arranged on the board in a way that you will find them during a game, the experts' memories were far superior to that of the beginners. However, if the pieces were arranged randomly, there was no difference between the memories of either group. One would think that experts have better memories, giving them an edge at chess. However, this study has proved that wrong and shown that their memory is actually no better than that of a beginner. What the expert does have is a knowledge structure that helps them remember particular kinds of information. And then when the information matches this knowledge structure, they can remember easily. But when the information does not, like in the random pieces of chess, the expert can remember. This study has been replicated in different fields, like in electronics, music, physics, and naturally, the computer programming space, where authors found similar results, confirming this basic concept. In a series of experiments, participants were given different programming statements to memorize. When a complex problem is encountered, our tendency is to divide it into parts. We group information, which helps with memorizing. This phenomenon is known to psychologists as chunking. So when the program statements were arranged in a sensible order, experts were able to better remember them, better than beginners. But when the statements were shuffled, the expert's superiority was reduced. Layout is a useful clue to the structure of a program. Whereas the computer might care exclusively about braces or begin or end statements, a human reader draws clues from the visual presentation of the code. So let's look at some layout streams. The program shown here is syntactically correct. It compiles. It has comprehensive comments, good variable names, and clear logic. I invite you to read it for yourselves. What the code doesn't have is good layout. Now, this is an extreme example. So let's look at a less extreme one. This code is exactly this. I think everyone will agree that this layout is so much better. However, the code is still not very readable. It is crowded and therefore has no clues to the logical organization. The first example was extreme, but the second one isn't at all uncommon. I've seen code like this in our code base and during code reviews. This code is formatted for the computer. It was not meant to be read by humans. So let's look at an improvement. Now, this is so much better. It is more readable. And you might say, well, these are things that tools like Spotless or Reformant can fix. But there is something about grouping and semantics that those tools cannot fix for you. Vertical openness between concepts is something that only you, the developer, can establish. This extremely simple rule has a profound effect on the visual layout of the code. Each blank line is a visual cue that identifies a new and separate concept. As you scan down the listing, your eye is drawn to the first line that follows a blank line. We also rely on the indentation scheme. This allows us to quickly hop over scopes that are not relevant while scanning our file. And the only difference between this example and the first two is the use of white space. The code and the comments are exactly the same. So white space is only of use to human readers. The computer will have interpret any of these three codes exactly the same way. Let's look at this other piece of code. We should think of systems as stories to be told, rather than the programs to be written. Your functions should be small, well-named, and nicely organized. The real goal is to tell the story of the system. The functions you write need to fit cleanly together into a clear and precise language. Think of it as a well-written newspaper article. You scan it vertically. At the top, you spec a headline that will tell you what the story is about and allows you to decide whether it's something you want to read. The first paragraph gives you the synopsis of the whole story, hiding all the details while giving you a big picture concepts. And as you continue downward, the details increase until all the dates, names, quotes, claims, whatnot are explained. Code is a communication tool. We should use it to communicate. Sure, it needs to be machine readable and executable too. Should compile, but that is not really its primary goal. If it was, then we will still be programming by flipping switches or writing machine code. So the small part of any programmer is writing a program that the computer can read. The larger part is writing so others can read it. . And you have probably seen this before. You get to read code 10 times more than you get to write. It should tell you something. You should do your very best to write good code, even if it makes writing it harder. Optimize to reduce thinking rather than to reduce typing. The fundamental theory of formatting states that good visual layouts shows the logical structure of a program. It is not merely a matter of aesthetics that programs should be written in a particular style. Rather, there is a psychological basis for writing programs in a conventional manner. They affect how easy it is to understand the code, review it, and revise it months after you wrote it, and also affect how easy it is for others to read it, understand it, and modify it long after you're gone from the project. The visual and intellectual enjoyment of well-formatted code is a pleasure that few non-programmers can appreciate. But programmers who take pride in their work derive great satisfaction from polishing the visual structure of their code. This is a series of drawings by artist Pablo Picasso. It's titled The Bull. And it consists of 11 stone prints, each one stripping away a detail until a few lines remain. What we wanted with this artwork was to capture the essence of the bull. This part of the tech talk is inspired by Rich Hickey, which is the creator of Clojure. Who is the creator of Clojure? Simplicity is something fundamental in our profession. You are always talking about it. But what does it really mean? So very briefly, some definitions. Simple comes from Latin simplus, and it originated from medicine. It basically means that it's constituent of one element or one part. You can construct it with complex, which means to combine things or to braid them together. So what does this mean in the world of software? It means that is one component that fulfills one role, that has a specific task, that is about one concept, security, access management, price calculation, so it's one-dimensional. What it does not mean is to have one thing, to have, for example, a class with only one method, or to only use singletons. So it is about the interleaving, and that's why there is a good analogy here with the knots. And finally, simplicity is objective. You can look at it and determine how simple something is by virtue of its nature, regardless of how familiar, how near or acquainted we are with the concept. This quote goes back to the Picasso painting. Simplicity comes when trying to pull things apart into their essential natures. So think of it as undoing the knot. And this is what good software design is made of. It's not about grandiose plans. It's about taking things apart. It means to look at a piece of code and be able to say, this code does too much. Let's pull it into two separate things, two classes, two functions, two modules, two microservices, you name it. So let's look at simplicity in context. We have a case here of list and order. I think everyone here probably knows what a list is. A list is a sequence of things. However, when you have a list, you have to ask yourself, does the order in the list matter? A list where the order matters forms a complex structure, because it forms a structure with semantics. And if order matters, complexity has been introduced. So why should you care about lists and orders? Well, like I said, it's a source of complexity. It ties one thing to the next, and it couples the implementation with the clients. So if the order suddenly changes, whoever depends on that order will need to change too. Now comes the interesting part. You can take this concept of list and order and apply it in other contexts. So for example, positional arguments are an example of this problem. If you want to add a new argument in the middle of a function signature, you will have to change all places where the function is called. And the colors change is another example. This is one way in which microservices can interact. Does it look familiar to you? A equals B equals C equals D. This is an order list where the order matters, and the system is harder to change. Compare it to one that says, take whatever A creates and put it in a queue, and B reads from that queue. If I want to change that program, I don't need to touch A. I can make something else start consuming whatever A produce, and A is unaffected. Now, this doesn't mean that we have to put queues between everything, but this is an architectural resource that reduces complexity. And there are more examples like XML versus JSONs or functions with side effects. So we can only think of a couple things at a time. And you can think of this as mental juggling. The more balls the program requires you to keep in the air at once, the more likely you will be to drop one of the balls, leading to a design or coding error. If I'm working on a project or a class and I need to pull this entity that is not simple, I get this knot of other stuff connected to it. So I'm forced to consider those things together. And complexity, this tying of things together, is going to inevitably undermine our understanding. And if we don't understand something, how can we expect to change or fix it or make them better? So the more you do keep things being complex, the more difficult it is to do software that is reliable, that you can change and enhance. Good code matters. We know this to be true because we have had to deal with the lack of it for a long time. Now picture this, and we have all been there. We start a new project, it's a greenfield project. We go to stand-ups, everyone is excited. We have our product owners, we have our rituals, everything is great. The first week, we start writing code, the feature is working, we do our demos, we ship fast. Now it's the second week, third week, and months into the project. And we will get new requirements asking us to do more. And we have to take what we have and we have to make it do it better or do it differently. And as we keep working, there is a new participant in the stand. Growing in the corner is the code we have written. It's the elephant in the room. Because once software grows a certain size, complexity and the elephant will dominate. And you want to reduce complexity so the elephant can do more. And it doesn't matter what kind of processes or methodologies you have. If you have a complexity elephant, you're just trying to apply these processes to push the elephant. So where is the failure? And you as a developer probably have been slowed down by messy code. We want to move fast. And as we move fast, we make a mess. And as the mess builds, the productivity of the team decreases. And we get slower and slower because the quality of our code degrades. We have all looked at the mess that we just made, and we have chosen to leave it for another date. And we all decided at some point that a working mess is better than nothing. We all said, oh yeah, we will go back and clean it up later. But hope is not a strategy. So a rule or idea that you can follow in these periods is whenever you have to write a small change or fix a thing, don't limit yourself to fixing that code. Also do some small acts of reparation. And the act doesn't have to be something big. Change one variable name for the better, break up one function that is too large, eliminate one small bit of duplication, or clean up this complex if statement. If we all check in our code a little cleaner than we check it out, the code will not rot. Can you imagine working in a project where the code simply got better as the time passed, or a code base that never becomes legacy? If you have read Atomic Habits, you're probably familiar with this author, James Clear. We are so often convinced that change is only meaningful if there is some large, visible outcome. How many of us have made big New Year resolutions? Become healthy, start a new hobby, start traveling. We put so much pressure on ourselves to make this type of big bang day-night improvements. On the other hand, improving just 1% is not notable, but it is the effect of a small gains over time that compound to be something meaningful. If you get 1% better each day for 1 year, you will end up 37 times better by the time you're done. This is why small choices don't make much of a difference, but add up over the long term. So choosing a poorly named variable or passing too many parameters to a function doesn't seem to make that much of a difference, right? But if every day we commit to our code bases and we let these things slip through, the code base will inevitably decay. And this is known as technical debt. And let me be clear, there is nothing wrong with technical debt. How many of us have bought a car or a house with debt? However, the key difference between a technical debt and a mess is the same as a well-planned home mortgage and a credit card shopping spree. True technical debt is a careful considered deficit in feature, structure, but never intentionally bad code. So paying down technical debt via refactoring is necessary in order to keep the code in a state where it's viable to extend it and maintain it. So to avoid a situation where you need to do a complete rewrite, leading us to this refactoring big bands, you can follow this extended version of the Boy or Girl Scout rule. If you see a small issue that can be fixed quickly, fix it right away. If you see an issue that may take time to fix or you're unsure about, report and flag it either in your editor, Jira, or other tracking system. And third, and most importantly, track big issues continuously, prioritize them, and make them part of your sprint. So switching gears a bit, how do we define the software development process? If we can draw analogies between software development and other professions, we can get insight into the software development process itself. And although computer programming doesn't match any of these professions exactly, we can draw some useful parallels to these fields and get insight from the techniques they employ. So what are the most common analogies used? Computer programmers are often compared to artists, architects, engineers, and craftsmen. Great artists practice their skills to develop their talents. They explore new ways of presenting their message. Great architects know how to build upon existing designs using standard components to create custom objects. They understand cost constraints, safety issues, and requirements. And they understand the relationship between form and function, as well as the need to fulfill the customer requirements. Great engineers recognize the benefit of consistency. They document and automate development steps. They encourage the reuse of existing designs to deliver more robust and cost-effective solutions. And finally, good engineers define and provide procedures and policies. Great craftsmen train and practice their skills under the instruction of a master, with the ultimate goal of becoming master themselves. This metaphor emphasizes the quality of the individual, such as their problem-solving and organizational abilities. A bad analogy, compare ourselves to bricklayers who code, building a static and hard to change the structure. So I want to introduce a new analogy. This is your code base. The code base is organic. It needs continuous care. You need to look after your code. When we go out on vacation, when new vulnerabilities are found, when other developers need to make changes to our code base is constantly being subject to an evolving process. So when the code grows in an unexpected direction, we must be willing to cut, chop, and arrange nicely so that a new living thing can grow. We should think of software engineering as being gardeners of our own code base. So how do we write great code? To write great code, you must understand what makes code great. You need to use the best tools, coding techniques, procedures, processes, policies when writing code. In addition, you must constantly increase your knowledge and improve the development process you use to enhance the quality of the software you develop. That's why it's important to consider different approaches to software development, to understand the software product and to choose the best approach. So if by this time you haven't yet figured out, this is a tech talk on clean code. So what is clean code? Clean code reads like well-written prose. Code formatting is important. It is too important to ignore it, and it's too important to treat it religiously. Code formatting is about communication, and communication is the professional developer first order of business. Clean code does one thing well. We discussed the true meaning of simplicity and its antagonist, complexity. Simplicity is about one concept, one idea, one dimension. We achieve simplicity by pulling things apart until we get to its fundamental nature. And clean code was written by someone who cared. We talk about this new way of thinking about the software development process. The code base is a garden. We are the gardeners and caretakers of our code base. So what I want to ask you today is, what will you choose? Because if I'm being honest, I find that the content of clean code is pretty obvious and almost natural to most developers. We have heard this many times before. But if that's the case, why do we need to keep talking about it? Why do we are still dealing with these problems? And I believe what makes a difference is how you choose to behave. If you choose clean code, you must remain vigilant. Pay serious attention and consideration. This must be important to you in all the things you do. We need to develop sensibilities. Am I doing one thing? Has this become braided and intertwined? Is this layout considerate of my reader? And doing this work makes everything else easier, because we don't make quality and speed at odds. We don't need to sacrifice one at the expense of the other. Clean code enables change. It is an opportunity. It is the source of agility. We want to be able to climb the next mountain. But if you're dragging an elephant around, you're never going to be truly agile. So small things matter. And let's be real, in programming, it's always the small stuff that seems to get at us. Whether it's a forgotten semicolon, an uppercase that should have been lowercase. But the more you emphasize on a strong standards and a fix it now, not later mentality, the better your code will be. And it must start with you, the developer, owning the importance of addressing the small stuff. And the better you get at addressing the small stuff, the sooner you can start sweating the big stuff. So, do you remember our friend back in space? Chris Hadfield has a struggle for what seems like hours to regain his vision after having his eyes watery by an unknown substance. He starts doing everything he can to unblind himself, shaking his head and blinking repeatedly. Vision control is aware and trying to narrow down all possible causes. Eventually, he sees a little bit. And even though his eyes sting and everything looks cloudy, he's able to successfully carry the 8-hour mission. Later, discussing what went wrong, Mission Control tells him, "Do you remember to use your anti-fog stuff?" "Of course," Chris replied. "The night before, I'll polish the visor of the suit so we don't fog like a ski mask." "Well, I think you didn't do it perfectly. Probably you didn't get it all off." "So you're telling me that a spacewalk with a multi-million dollar piece of equipment that is absolutely vital to the construction of the ISS was jeopardized because of a microscopic drop of cleaning solution?" When he went out for his next CVA 2 days later, he wiped off his visor so rigorously that he was surprised it didn't drop right through the thing. Later, NASA will change the cleaning solution, but in the meantime, all astronauts will go fanatical about wiping their visors. That's why it's so worth sweating the small stuff. And in our lines of work, it's all about the small stuff. So I want to close with this quote from Uncle Bob that says, "Quality is the result of a million selfless acts of care, not just of any great method that descends from the heavens." That these acts are simple doesn't mean that they're simplistic, and it hardly means that they're easy. They are nonetheless the fabric of greatness, and more so of beauty in any human endeavor. To ignore them is to not yet be fully human. Thank you so much for your attention.